Or let's do a confidence interval for mean, useful websites. I'm going to go grab some data that StatKey gave me and I put in my Google Drive. And I want the Mindset Matters data set, which we've talked about a couple times before. There it is. And I'm going to make a copy of this so as not to mess it up. Actually, no, I don't need to make a copy because I'm using StatKey. I just want the BMI. And usually when I copy from a spreadsheet to StatKey, I don't copy the whole column because there's a shitload of empty cells. I'm just going to copy everything. Oh, there's some more down there. Okay, there it is. Copy that. And then I'll look up what that means. We really need to know about the sample and what BMI means. So we'll look that up in a sec. I'm going to go over to StatKey next. And in StatKey, we're doing a confidence interval. Which option do you think I want here? There's a whole bunch of different ones. Single mean, right? I have numbers. I want to find out what's the confidence interval for the mean on those. Select that. And then we just edit in our data. So I'm going to delete those, Control A, selects all, delete, Control V, paste. First column, I don't have a first column, but I did copy a header, right? Yeah. That's important that you check off the box about a header, because if you check that off, but there isn't a header, it's going to use the first number as a header, which means you're one number short in your data set, and it won't quite be right. So pay attention whether you have a header there. All right, remember the procedure from the other day for getting a graph? I put the data in and then generate thousands of samples. How many? Like 6,000, yeah. So let me just whack 6 times. And I mentioned, depending on the data set, like my laptop, which is like reaching out of usefulness, sometimes it just goes, just stops. And my screen locks up. So if you're having trouble with that, it's unfortunate. Find another computer, borrow a friend's, check with grandma. All right, so once I have that, then I click two-tail, and it's going to put 95 in the middle. We could change 95 to whatever we want. We'll do that later. I'm just going to stick with 95, and it's giving me a confidence interval. So this is saying that average BMI of a population is somewhere between 25.49 and 27.43-ish, 436, right? This is not describing the sample here. The sample information is up here. The average BMI in the sample was 26.462, and the standard deviation was 4.251. The standard deviation of this graph is called standard error. Notice that's 0.0495. Much smaller than the standard deviation of the sample. That's not the standard deviation of the population. That's the standard deviation of what we call a sampling distribution. Okay, so I'm going to I'm going to try to interpret what this tells me, and then I'll go into more detail about how those standard deviations are different. So I'm just going to screenshot this sucker. That much. Let's see, to interpret this, add to new page, I'm going to need to look at the data set description and remind me what this is a sample of. My recollection is these are hotel maids in New York. So let's see, data set descriptions. I had linked back here. Search for mindsets. Go. All right, is that the right one? Nope, down here. Perceived exercise of maids. I grabbed BMI, which is original body mass index. Body mass index is calculated by taking the height and the weight. Take the weight, divide by the height squared. If it's in kilograms and let's see, theirs is in pounds. So that means they had to do a conversion factor. I think it's like 703 to convert from imperial to metric. But you could look that up. But bottom line, the number is BMI, body mass index. 75 female maids. Okay, so we have a sample of 75 female maids. That's the sample. What's the population of interest here? Is it, what's that? All US maids? Yeah, it might be all right. Okay, it was just in New York. Are you at New York maids different than maids in Oregon? I don't know. Are maids different than adult women in general in the US? Maybe, maybe not. I don't know. Okay, so somebody might say, oh no, I think, yeah, that's probably representative of all women in the US. Okay. Some people might say, no, this is just US maids. Somebody else might say, I bet the target population is just maids in New York hotels. It's not stated here. So it's our best guess, target population. I'm going to say it's maids in the US. That seems like a reasonable target population for this sample. But I think when they did this study, they were looking at women in general. All right, so back here, let's define some things. We have sample size n equals 75. We have a mean x bar, and that mean was, oops, I didn't copy that over. Go there, 26.462, 26.462. What does 26.462 represent? Average what? BMI. BMI. Yeah, it's just average body mass index. So this is average BMI. Okay. And we're going to use that to estimate the population. Okay, so the sample mean is called X bar. Anybody remember what letter we use for the sample, for the population mean? Mu, yeah. So this is the sample. We're using this to estimate the population, mu, and I'm claiming that mu is the average BMI of maids in the US. But I don't think it's unreasonable to say it's adult women in the US. So based on this, I think the average BMI of maids in the US is about 26.462. What's the threshold for obesity in the US or in general from BMI? It's 30. So this average is under 30. So on average, maids in the US don't seem to be obese. Okay. My recollection is 25 and over, or over 25 is considered overweight. So on average, they're just a touch overweight if 25 is the threshold for overweight versus obese. All right, next. Is the average BMI of all maids in the US exactly 26.462? No, there's a margin of error there. Find the margin of error. Whip out a calculator. What's my margin of error here? Based on this graph right here. Yeah, what's the margin of error based on this graph? Write something down. Yeah, get out a calculator, write something down. I'm not doing it. Oh, you can't read them?
Yeah.
Okay, let's, the bottom one is 27 point, the right one, 436, and the other one is 25.493. Okay, whip out a calculator. Tell me what the margin of error is based on that interval. Got one chat that says it's about 0.9715. Not on that. Okay, cool. So we think the margin of error is 0.971. And again, the way we find that is we take the upper number, subtract the lower number, and we divide that by 2. So that's our margin of error. So I can draw that in here too. It's about the distance from the middle to the right or the middle to the left. So just rounding numbers a little bit, I could say that the average BMI of maids in the US is within 1 of 26.5. Right, because the middle is about 26.5 if we rounded it to 1 decimal place, and 0.97 rounds to about 1. Okay, or I could say the average BMI in the US for US maids is between 25.5 and 27.4, would be another way to state it. So what I'd like you to do is look back at those statements we made before, or I made before, about BMI. I had two versions of it. This one here, where I say we're 95% confident that blah, blah, blah is between blank and blank. Or same start, we're 95% confident that blah, 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 whatever the parameter is within margin of error of center sample statistic. So make a statement like one of these for this information. This is called interpreting the confidence interval. Write something down. Write mine down and we'll talk. Here comes my version. And I'm thinking about this as like a publication statement. Like if I was working for the CDC and I had to write this up in a report, I'd probably just round to 1 decimal place. I think would be sufficient here. But I would have fine print that had more detail later. So this is one way to state it. And again, the formula for interpreting a confidence interval is always the same. It always starts off with we are some % confident, right? And this can vary. We'll vary that later. And then the next thing I just do is I describe the parameter. And the description of the parameter is almost the same as the statistic. The parameter refers to the target population. The statistic is just about the sample. Right, so this is about the parameter that we're trying to estimate. And then I just state what the confidence interval. What are the two numbers? What's the low? What's the high? Okay. Alternatively, I could have started it off the same, but I could replace that part with is within. And if I, let's see, as a percentage, that was what, 0.97 to the nearest 1/10 of a percent is going to round to just 1.0. We'll just call it 1. So it was within, oh wait, it's not a percent, is it? It's a BMI. Yeah, we're just going to call it 1. It is within 1 of, and our middle number was what, 26.5-ish? Yeah. So I could have, instead of ending it as between those two numbers, I could say it's within the margin of error in the central sample statistic. Two ways to write a confidence interval. Questions on that? Okay. Next, I want to go back to the graph that StatKey made and explain again what it means. So copy of this to scribble on. And I want to compare this with, shrink it just a touch, the original data I started with, because I want to kind of get across the difference. This over here. So I went back to the data set, Mindset Matters, and I made a histogram based on those BMIs. And is this a good histogram? The answer is no, it's a shitty histogram for several reasons. One, the titles suck. Two, the numbers at the bottom are not nice. All right, so I'm gonna nice it up, just, that's the right thing to do. Let's see, I'm gonna try jumping by 5 maybe. Maybe 4. Eh, 2. 2 is probably too many. All right, there's no best histogram, there's just options. Okay. 3 is a nice number, it's a magic number. All right, and then again, this would be not just histogram of BMI, but BMI of hotel maids. And what's the vertical column? The horizontal is BMI, right? BMI could be 18, 21, 24, and so on. What's the 5, 10, 15, 20 doing? Frequency. Frequency what? Maids, yes, counting how many maids. So I might call that number of people, right? Or number of maids. They're people. Let's call them number of people. So let's fix that while we're here. So we could call it frequency, but we should be more specific. Frequency of what? And let's just use the word number of people. That's better. Okay, let's copy that sucker. Put it in the notes. Did copy? I gotta use this copy button perhaps. Okay. Are these the same graph? Not even close. Different scales. This one has 75 points, and those points are hidden in those columns. I could see them kind of as points by changing the settings on the histogram to show divider lines. So now there I can see all 75 maids. Each one is a little rectangle. Okay. How many rectangles are there here? 75 from my sample. If I look back here, there's a shitload of dots here. How many dots? 6,000 dots. What does one of those dots represent? Not a person. Not exactly one sample. It's the average from one sample. So we have 6,000 points. Each point is just the average of the 75 that got selected for that sample. How are they selected? Well, each of the maids, the analogy is each of the maids, the computer made a card for them. Right? There's maid 1, maid 2, maid 3, all up to maid 75. And on the card is their BMI. And to get one of those points, what the computer to do is shuffle the deck, look at a card, write down the number, put the card back in, shuffle it, look at it. They did that 75 times and then average those 75 numbers. That's 1 point. And the computer did that process 6,000 times. Right? It would take us days to do that without the computer. This is what's called a sampling distribution. Is this a distribution of the population BMIs of all maids? The answer is no, it's not that either. What I would expect from the population of all maids is it would look similar to this histogram. The low would be around 15, the high would be around 40, the average would be around 26-ish. I would expect the population to be similar to this if the sample's representative. It would have a similar spread. It would have a similar symmetric to it or similar skew if there's a little skew in there. Okay. Notice how narrow this distribution is in comparison. It goes from like 25-ish to 28-ish. That's much narrower than the sample. And the sample histogram is really going to look like the population histogram, except there's going to be a shitload more people in the population, right? Hundreds of thousands or millions in the population. This only has 75. Okay. So I mentioned that the other day. There's 3 kinds of distributions that are floating around at the same time here, and they're all slightly different. We have a sample distribution, which is the histogram of the original data. That kind of represents what the population histogram probably looks like, but the population is just a ton more people. It should have a similar spread, similar mean, if the sample is represented. What a sampling distribution does is says, well, if that right there is a representative sample, we can use it to make up other kind of representative ones. And when we put the cards back in the deck, sometimes the low numbers come up more often and you get low means over to the left. And sometimes the higher BMIs come up more often, randomly, and you get some higher ones. But on average, what's the middle of this distribution look like? Does it look similar to the middle of this distribution? In the middle of this distribution, according to the mean, is about 26.5. In the middle of the sampling distribution is about 26.5. Is it exactly the same as the mean of the sample? No, not quite. If we go back to StatKey to double check that, uh-oh, my computer's struggling to do this. This is supposed to be a high-end gaming computer. Come on. All right, we're gonna have to reload, recalculate. I lost my data. Here, okay, so we're gonna edit the data. We don't want the prices. Boom, boom, boom. Oops. There. All right, and then so we put our data in. We're doing a mean, not a proportion. That's important. And then generate. Detail. Okay, similar to before, not exactly the same, but similar. The actual sample mean was 26.462. This time in the sampling distribution is 26.45, a little different than before. But what's going to happen all the time is the mean of the sampling distribution will be pretty damn close to the mean of the sample. And either of them is about what we think is going on with the population. Since we don't have all the population data, we can't say it is that number. We can say it's near that number. How near? How do we measure near? That's what the 95% tries to do. It said, this is what we think is it's near. It's in between about 25.5 and 27.4, which is, I think, what I wrote down before when I went to 1 decimal place. Or I could say it's within 1 of about 26.5. Right, 2 ways to look at it. All right, next tough thing. So we're getting down what it means to interpret it, to get a confidence interval, right? And we can have StatKey generate one for us based on a sampling distribution, which needs a good sample. So hopefully that's a good sample. I think it probably was. And then we know how to interpret it. There's a couple ways to do that. What does it mean to be 95% confident? Okay, that is a little hard to deal with, but there's really only one way to state it. So this is an interpretation of a confidence level, not a confidence interval. Interpretation of a confidence level. And in this case, we're using the default of 95. We'll try another one in a minute. 95% of similar samples will have a confidence interval that contains, in this case, what's our population parameter? mean BMI of hotel maids. So for this one, it would be contains the actual mean BMI of hotel maids in the US, whatever the parameter is. So 95% of similar samples. So if we go out and we collect another sample, random sample of 75 hotel maids, we could use it to generate a confidence interval. It'll have a slightly different mean. It'll be a slightly different interval. It'll be around where this one is. And that one might contain the actual one. The first one might contain the actual one. If we do 100 different samples, each of 75, we would expect about 95 of them. The actual real mean is in 95 of them, and 5 of them just totally missed it. Do we know if ours actually caught it? No. We don't know if ours is one of the 95% good ones. We just hope it is. Okay, so that's all it means. With repeated sampling, with a 95% confidence level, 95 out of 100 of those samples will make an interval that actually find that the real mean is in there, and 5% of them will not. That won't happen. It doesn't tell me that 95% of BMIs are in that interval. Totally not that. Right? And again, we can look at the graphs to get an idea of that. The 95% spread in the BMI is 25.5-ish to 27.4. But if we marked 95% of the original data, that's probably going to be around here and here-ish. So for this sample, 95% of the maids had a BMI somewhere between 18 and 36. It's roughly that. I'd have to do some work to figure that out, right? Totally different spread than this. Okay, so it's not 95% of maids' BMI. That's not what the 95% means. That's a common misinterpretation of what it is. And the book goes to some other, this is not what it means. So make sure you look at that in the book. There's other misinterpretations before. So this is the only reasonable way to interpret the confidence level. So far from what we've done, I expect that more often than not, you can, given some data, create a distribution in StatKey. Based on that distribution in StatKey, you can come up with a confidence interval. Based on the confidence interval, you can tell me what the margin of error is. And based on the interval, you can tell me what the heck the interval is telling us, right? That's this one back here. That's the interpretation of the confidence interval. Okay, so I'm hoping you guys can do that like most of the time. This is slightly above and beyond what I expect you to interpret, but I need to let you know what 95% means. So if you nail that too, then you're like A+ in this class. All right, so we've been working hard on this for an hour. We should take a little break. Then I'm going to give you another data set, and we're going to generate a confidence interval. And then I've got a little quiz we're going to do together.